Hello everyone, my name is Negar and I'm a PhD student at University of Waterloo. Today I'm going to present PREME, which is a preference-based meeting exploration through an interactive questionnaire, and this is the outcome of my internship at Microsoft Research. Can you think about a situation where you have an idea of what you want to know, but at the same time, you don't know what you want to know? It's like you have a complex information need, and the more you know about it, the clearer the information need you have. For example, let's imagine a situation where you have missed a meeting. In general, you definitely have an idea of the topic and who were the speakers, but you don't know exactly what happened in the meeting. And to different people in the meeting, different topics might be important. And you might want to know specific topic that were discussed. But because you were not attended the meeting, you cannot raise specific question. In this case, a general summary would not be useful because you're looking for very detailed information. The goal of our work is to guide users to explore meeting by minimizing the effort from user perspective and to find out what they can ask based on what they would have known. If we want to define the problem more formally, we say that given a meeting transcript, we propose a questionnaire in which the inputs are the user's preferences and the output is the possible questions that one might have raised from the meeting. We want to minimize the number of interactions from users to gain the most out of their preferences and to be able to show them informative questions based on their interests. The questionnaires should have these properties. It should have high coverage. It means that it covers most part of the meeting. The answers in the questionnaires should be answerable. So answerability is another quality of this questionnaire. And it should not be redundant and not have so many repetitive questions. And also, it should minimize the user's effort as much as possible. PREME has the following workflow. Given a meeting transcript, first we extract different segments of the meeting based on the topic that was discussed in those segments. And from each segment, we will generate questions. Given that we converted the whole meeting into a pool of questions, we want to extract what is the subject and what was talked about that subject in those questions. For example, in this example, we have what are the requirements for X, where X is the subject, and what was discussed about the subject is the requirement, which we call it as aspect. After that, because we might have different subjects and aspects that were discussed in each of the segments, we need to normalize them to be able to represent each segment with one unified subject and its several aspects. And finally, following all these steps, we were able to generate the questionnaire. We'll go through each of these steps of the pipeline one by one. For the meeting segmentation, we leverage out-of-the-shelf unsupervised topic segmentation of meeting with bird embeddings by Solbiati et al., which basically it computes bird embedding for every n utterances of the meeting, and then it divides the meeting into blocks where it has the most differences, where there is the highest differences between each blocks, and then it will derive some boundaries between the meeting segmentation. Some of the advantages of this method is that, first of all, we will not throw out any part of the meeting. We will keep all of the meeting, and we're just setting boundaries in between. It is unsupervised, so it can be extended to any unseen data. And also, it has shown state-of-the-art performance on very similar data sets. Now, let's say we extract segments from the meeting. It's time to generate questions. We leverage GPT-3 to generate questions from each meeting But as we all know, one of the biggest disadvantages of such large language models is hallucination. In order to avoid hallucination, we propose to use topic normalization um, that I'll be discussing shortly. Okay, so let's say these are the questions that were generated by any large language model. What we propose is that we propose to extract subjects and aspects of each of the questions. For example, as shown here in these examples, what are some of the pros and cons of speech recognition? The speech recognition would be the subject, and pros and cons would be the aspect. We designed a heat app to collect the data using UHRS crowdsourcing, and each question were judged by 2 fully trained annotators. We collected 1,000 questions that were generated by GPT-3, and as you can see here, you can see a screenshot of how the heat app would look like. Now that we have all the questions followed by their subjects and aspects, we train the CRF model to extract the subject and aspects from rest of the questions. And as you can see in this table, our CRF model was able to get pretty high and acceptable precision, recall, and F1 score on both extracting subjects and aspects. Now, let's say we have the predicted subjects and aspects for each question. It's time to normalize the subjects to avoid hallucination and also to present each segment with one unique subject. So we propose to build a fully connected weighted network based on all the subjects from all the questions within a segment. For example, let's say these are the extracted subjects from the questions from a given segment. We build a network within all these subjects, and the edge weight would be the similarity between each of these subjects. Then we measure node importance metrics such as page rank to find which of these subjects are the one that is most similar to other one, and it's the most important node, and it's able to represent that network. For example, in this example, education is the one that got the highest page rank, so we can represent all of these subjects with education as the most general one. In order to run experiments, we use QM-Sum dataset. QM-Sum dataset is a query-based summarization method and dataset. It has over 1,800 question and goal summary pairs and over 230 meetings. And the method that they leveraged in QM-Sum paper was locate, then summarize. So it's like given each query, first we locate which part is the relevant part of the meeting to that question, and then they will summarize it. QM-Sum has its own limitation. First of all, the answers to the question each time is like more than 10 utterances or like 200 words, and also they are not real questions. By that I mean, if you don't know enough details from a meeting, you cannot issue such a detailed and specific question. So the questions in QM-Sum dataset actually cannot be raised by someone who were not in the meeting. So our goal in this paper is to be able to propose such a detailed questions to someone who has missed the meeting. In order to evaluate our proposed questionnaire, we propose some criteria to assess. First of all, it's coverage. By coverage, we mean that a better questionnaire is the one that covers more of a meeting. So it's like when we have the questionnaire and the questions in the questionnaire, we will find the answers for those questions by the locator from QM-Sum paper, and we will locate the relevant part of the meeting in a meeting, and a questionnaire that covers more part of the meeting is a better one. As you can see in this table, our questionnaire were able to, on average, cover more than 80% of the meeting. The second criteria for a good questionnaire is answerability. We don't want to generate and include questions that they are not answerable. Therefore, we use one of the state-of-the-art question answering methods from Hugging Face, and we try to find the confidence score for how confident the model is that this is the answer to these questions. In this figure, we show the histogram of confidence score for question answering model on generated questions from PREME, and as you can see, majority of generated questions has a pretty high confidence score. It means that they are answerable. Lastly, I want to show you a research prototype of our PREME tool, which in the first part, you can select which meeting you want to explore. And based on that, we will show which subjects are which subjects have been discussed in that meeting. And after that, once you select the subject, you can see the aspects that were talked about that subject, and you can select those that are more important to you. And finally, the tool will show you the suggested questions based on your preferences. Okay, so the main takeaways from this paper is that we propose PREME, which is a novel framework to enable meeting exploration based on users' preferences through an interactive questionnaire. We believe that by raising large language models, now we should find new ways to interact with these large language models, and PREME is one of them, which propose a new way of interactions between humans and large language models. Additionally, we propose a new method for subject normalization and also to avoid hallucinations of large language models. And since proposing a questionnaire was already a new contribution, we had to find a way to evaluate that because there was no previous work. We were not able to compare it to any baseline. That's why we come up with automatic evaluation strategy by measuring the coverage and answerability of the questionnaire. Lastly, we open source the collected data, which is 1,000 questions with their subjects and aspects, and you can find it on github.com/microsoft/prem. Thank you for watching this video. If you have any questions, please don't hesitate to contact us.